Hi everyone, so I'm going to present SketchSliders sketching widgets for visual exploration. So this I'm Theophanis Tsandilas from INRIA and the University of Paris Sud. So this is work done with Anastasia, Bezerianos and Thibaut Jacob. So let's start with some context. So this is an example of visual high resolution large display that we have in our lab. And actually such displays allow users to view a large amount of visual information. They also have many applications in domains that are related to visual data analysis. The main problem, actually the main challenge, is how you interact with such displays. As actually users are often mobile, they have to move closer to view details or move a step backwards to see overviews of complex data. So there are also users, as you see here, actually they need in such environments access to interactive controllers and a large number of controllers. So here what you see two very representative examples of traditional user interfaces for filtering data. And actually at the left you see that sliders that are used to filter information are also visualizations by themselves, right? You see that they're augmented by some distributions that show some histograms. Okay, so these actually controllers are very powerful, have been used for a while. The main problem is that they are very rigid and they are very tightly coupled to the visualization of the controller. So what we try to do in this work is to push their limits to see how further we can go. Okay, what can we do and what shape we can give them. So first, we want to encourage mobility in this environment, right? So by decoupling the visual space of the large displays in the wall, where information can be very overwhelming sometimes, and also having this personal exploration space on the tablet where interaction takes place. Okay, so this is actually the interface on the tablet where users will let users to draw their controllers on the fly when they need them. Okay, customize the shape, give any shape they like, and add on top of them, of course, notes and annotations. Okay, so this is important. Now, so what SketchSliders are sliders that are drawn by the actual users. They can take several interesting shapes that we're going to see in a while. So let's first start with an example. Okay, let's imagine that we have this data set with temperatures, average temperatures in different countries, and we want to show information, show the average winter temperatures in Germany and France. And you see here a scatter plot and a bar chart, and in blue we see the selected data points. And let's see how we can express this query with SketchSliders. First example. So what you see here, it's an Android application running on my mobile phone. And you see 4 different sliders with different shapes. Okay, so the first ones are the main sliders that express the main query, right? The countries and the month for these countries. So there is another slider here that actually selects the positive temperatures, but now it has been deactivated. That's why it's faded away. It has been replaced by this temperature slider that shows the full range of temperatures. Okay, so you see here that the sliders are augmented with some visualizations, some distributions, and there are 2 different types. We have in pale yellow, we see the distributions of the full data set, while in blue, we have only the distributions, the relative distributions of the selected data. And what these distributions help the user is to get a very fast overview, approximate overview of the data and the queries without having to look on the wall, right? So the work on the tablet, they don't have to switch the rotation to the wall. So you see, for example, here that you can have approximate, this is the range of temperatures for this query. You see also that there are some interactive elements on top of the path of the sliders. So these are area cursors that you can move along the path of the slider, and first you can bookmark specific values on the slider, but also explore data values and select data values with them. Okay, let's start first to see some basic sliders for what we do. Let's assume that we try to explore digital cameras on different dimensions. We sketch the slider, and then we select low resolution in this example. So now we actually provide several crossing-based gestures, for example, to change dimension, remove, erase an element, or for example, a range filter, create a new range filter, move it along the path of the slider, yes. We also provide delta filters that select the delta range, a small range around a specific value, and we can move it around. And we have also draw slider cursors and move them along the path of the slider. As you see that the sketch sliders are synchronized with the plots on the wall, right? So we can filter them and filter the information directly on the wall. Now, as you see here, we can also hold and drag an extremum of the slider to change the range of the slider, and this reflects, also changes directly the range of the axis on the plots. Okay, so actually we're not the first to study sketching for visual analysis, right? So very representative is the work in Microsoft Research. For example, the most representative systems are SketchVis and SketchStory. Our main difference with the system is that we don't sketch directly on the visualization. What we sketch are the controllers. Right? So sketching actually allows for a lot of freedom, right? So you have a lot of freedom. You can sketch them in any ways you want. So the first thing that we try to think about when we start this work is what you can do with this freedom, right? How far you can go, and what new forms of interaction, data exploration you can imagine. So we conducted a very informal design sessions with some visualization experts, and we tried to brainstorm with them on top of a Wizard of Oz prototype that consists of simple paper, pen and paper, and some plots and filters that were shown in a vertical display that they were controlled with a mouse. So let's see some interesting examples that we came up with. So for example, what you see here is a bending slider that you have a corner to bookmark a particular value. So this is a circular slider for periodic variables. So what you see here is we graph the slider with a branch to have a higher precision and granularity. What we can also do, have a shape, a graphical shape, to express a function in order to control the viewing detail on our plots. And then, okay, and let's see how we have integrated these different shapes, different forms of slider into our design. So as you see here, I draw a bending slider where there is an automatic recognition of the corner. I can refine the value of the corner and then further annotate it with my pen. Then I can draw a circular slider, and I can associate it with a periodic variable, for example, the month of the year. So what a circular slider is a slider with no ends. I can graft branches of the sliders for better detail, granularity, can change the range of the sliders. You see, actually, what this branch is the proxy of the main, of the original slider. It has all the filters of the original slider. As you see here, I move the filter, and the filter of the original slider also moves. And I make an annotation in a cluster that I discover. What is more interesting is that I can add more branches, and I create more complex structures, which are arbitrary polytree structures here. Okay. So I can also draw transformation functions in order to zoom in a specific range of the data without losing context. So as you see here, I draw the transformation slider. This deforms my data on the plot. So here I can zoom in the lower range of prices. Okay. So let's see some more details about some of these designs. So for example, for branches, what you saw in the video, branches allow us to zoom in a specific smaller ranges of our data, as you see here, in this dimension. So here we create a smaller range, and what we can see here that we have a cluster here that was not visible in the original slider. So here we have more detail, you can see more things. And as we add more branches, we can dig incrementally into smaller and smaller sub-ranges. And as you see here, these are all instances of the same filter. So these are copies of the same filter. But you can see as we move from the first to the third filter, how we gain in precision and detail. Okay. So transformations. So a curve of a slider can express a transformation function. And the way that we define transformations, we use a curvilinear coordinate system. Okay, this avoids the problem of having curves that do not define valid transformation functions. And then we first apply this transformation to the slider itself. And in this way, you can see that the valleys, near the valleys of the slider, we have lower detail and precision, while near the peaks of the slider, we have higher detail and precision. And you can see how this transformation affects also the precision of the values on top of the slider. So here you see slider cursors, And you can see how the values, the precision of the values, the range that they cover changes along the path of the slider. Okay. So then the transformation also applied to the visualization of the wall by themselves. So we see here, for example, how we have deformed the x-axis, the temperature axis in this scatter plot, so that we can have more detail near the higher level, higher range, the highest range of the temperatures, between 20 and 25 degrees. You see the correspondence between the slider and the plots. Okay. So actually, I don't have time to talk about all the functionality of the sketch interface. So here we can mention that we can accommodate multiple queries. So for example, you see by means of sections. So here you see 2 different sections with 2 different sets of queries. In this way, the user actually can keep a history of his exploration, of her exploration, and go back later to refine these queries. Okay. So have a first evaluation of our design. We conducted a small evaluation study with 6 researchers with experience information in interactive visualization. Actually, they used our interface in interaction with a wall display that showed 3 scatter plots and 1 bar chart. And we actually encouraged them to think aloud about the task. During the task, there was a small training session of 20 to 30 minutes, followed by 2 open-ended tasks. Okay, over a data set of more than 1,000 digital cameras and 13 dimensions. So here I'm showing just a few examples, 3 examples of sessions. So you see here participant change the range of brands and then create a new branch to see more details about sub-brands. So here you see a price slider with 2 branches. And then as you see here, there is a sub-branch added on the previous branch. So here this user interacts with a transformation slider in order to have more details in the lower range of prices together with a simple linear slider. Okay, so I will just summarize some insights about what we observed and the feedback that we got from our experts. First, so I'd like to mention that all the experts were all the users were enthusiastic about being able to sketch their own controllers, the freedom that they have. As you see here, there's a user, for example, that says, this is a vertical dimension of the plot, so I'm going to draw a vertical slider on the tablet, so they have a clear correspondence about my personal space and the visual space there. They found also that the two visual spaces were very well synchronized, and as they were complementary. As participant 5 says here is that you cannot show all the information, all the data on your personal space on the tablet, right? So you need the wall. At the same time, you cannot interact all the time with the wall display. So you have to balance between them. Drawing also 1 controller at a time. A few participants said that actually this helped them to reduce the number of dimensions of the work. So they drew 1 dimension after the other. And this actually reduced the cognitive load as they complete the task. So it was here. Yes, this is what I want to say. Okay. So of course, the evaluation reveals some problems also. I'm going to talk about one problem, in particular, the visualization of the distributions that we have here. They gave us sometimes a false expectation about the underlying data when the number of data points was quite low. I'm going to explain, as you see here, there are 2 clusters that give the impression that you have 2 normal distributions there, but actually what this distribution represents are just 4 and 3 points, respectively. So as you see in the parentheses, in the cursor sliders, actually, you see the number of data points. So a way to address this problem, actually, thanks to suggestion by Pierre, here is possible solution is to change the visualization when the number of data points drops below a threshold. For example, one solution is to use beesworm plots, okay, in these cases. There are other limitations, of course, For example, we don't now allow users to change the shape of the slider after the slider has been drawn. And actually, several participants said that this will be quite valuable, particularly for transformation sliders, when the transformation is not what you want to expect at the beginning, when you want to refine it slightly. Collaboration and sharing is another direction that we like to follow in the future. We have to consider here that several, again, users said that although they would like to collaborate in such an environment, one environment, actually the sketching interface is something very personal for them, so they will be less comfortable sharing their nodes with others. Okay. And another also, of course, we don't have any reasons to believe that these SketchSliders cannot be used in other settings, for example, desktop environments, where you sketch them directly on the plot. So this is something that we like to see how this design could be adapted to this particular setting. So, in summary, I present a new sketch interface for visual and exploration in wall displays, and I introduce a new design of the SketchSliders for filtering information. So, I will be very happy to answer questions, not queries, questions. Thanks.
Robert Woodbury, Simon Fraser University. There may be a community that can really use your wonderful work, and that's the parametric design community. There's already a tradition in that community of building parts of the model whose only purpose is to control the rest of the model. Mm-hmm. So they build sketch parameter models as sliders to control other bits of the model. They'd really like this.
Okay, well, I'm very interested. Yes, we have to talk.
Hi, thanks. First, congratulations. It's a very, very interesting tool. I was noticing that in all the pictures, the users are looking at the tablet and not at the screen. So I was wondering if there was some confusion after they modify the filter in the sketch. When they look back to the screen, do they feel a bit lost when seeing a different result? Did you notice anything like that?
Yes. Actually, this is, it's a very good question. This setting actually poses this problem that you have to switch between two different displays, right? And actually, many of the designs, for example, the visualizations that we use on top of the filters, they try to reduce this problem, but this is a valid question. There were other actually aspects of the visualization to try to synchronize them that I didn't mention. For example, we use animation. For example, when you have changed the view of your plots, there is some animation that helps you to see the effect of your sliders on the display. But during actually the evaluation, we noticed that there were two different strategies. Many users actually, half of the users concentrate on the tablet and depended less on the wall. There were several others that depended a lot, looked a lot of the wall, and they tried to interact to see while they're filtering on the tablet, they were looking on the wall. But this is, yes, it's a problem that we try to address, but probably, yes, needs more further investigation. Yeah.
Cool, thanks.
Thanks.
Which is kind of related to the previous one. So in your pictures here, people are standing in front of the wall display, and that's one of the benefits of the wall display, that you can move around and look different parts. But in your study, when I look at the picture, people were sitting on the desk and putting the tablet on the desk and then manipulate there.
Yeah, this is true. Actually, during the study, we tried to simplify a little bit the situation, the scenario. The things that first, even to learn this interface, is quite many new things, and this is a lot of stuff. The reason that we do it in seated first is to have them, it's less tiring for that, okay. So also have the camera, because they were thinking aloud while they completed the task, so they had to be in a comfortable position and also had the camera to take the shots. So, yeah, we acknowledge this problem, but it's true that we'd like, to have a more extended study that covers some more realistic scenarios as the ones that motivated our work.